Okay, continuing on with surface area, a baseball. Okay, so we've got a baseball. In other words, it's a sphere. A baseball has a diameter of 2.8 inches. What is the surface area of the baseball? Okay, so what's the surface area of this ball? Well, first of all, let's look at it. We're given the diameter is equal to 2.8 inches, but we want radius. So what do? So you have to divide your diameter by 2. So 2.8 divided by 2 is equal to 1.4. So my radius equals 1.4 inches. Now the surface area of a sphere is 4 times pi times my radius squared. So this is 4 times pi times 1.4 squared. So let's find out what that actually is. And 1.4 squared. Oops, let's delete that. Let's hit the square button. And this is equal to 1.4 squared is equal to 1.96. Okay, so this is 4 times pi times 1.96 times 4 gives you 7.84 pi, and then times 3.14, and we end up with the surface area of my baseball is 24.6176. Now be careful. Look to see where they want you to round it. I've noticed in the homework that some of them ask you to round to the 4th place value. If that's the case, you have to use all 4 digits. On the first quiz, I noticed that some of you didn't look to see where they told you to round it, and you rounded it to the 3rd or the 2nd place value. They asked for 4 place values, so pay attention to that. So this would be inches squared. So that gives you that. What if you had to get enough material to make 255 baseballs? How much material do I need to make them? Well, you're going to have to multiply your surface area by the number of balls. So we're going to have 255 times 24.6176 to get your total surface area. So times 255. And I'm going to end up with 6,277.488 inches squared. But what if they said 1 square foot of the material cost we don't have a cost, but they want to know how many square feet. So what am I going to do? I'm going to have to change square inches to square feet. So keep in mind, here's a square foot. It's 1 foot by 1 foot, but each foot is equal to 12 inches. So therefore, to have your inches, it's going to be 12 times 12, which is 144 square inches, is equal to 1 square foot. So therefore, we're going to have to change this 6,277.488 square inches to square feet. So we're going to multiply it by this here, which is our distinguishing. Since my square inches is what I have, I'm going to go to feet, my feet have to go, square foot has to go on top, and my number of inches in that square feet have to go on the bottom, so that my inches cancel with my inches from the top to the bottom, and I end up with this number, 6277 divided by 144, and I'm going to end up with 43.5936 repeating. So depending upon where they want to round it, that would be your square feet. So you have to be careful to read the problem and see what they're actually asking you to do. So now let's look at some others. So let's look at the surface area of a cylindrical grain bin. Okay, a grain bin is a cylinder with a half sphere on top. So here is my grain bin. And it has a sphere on the top, half of a sphere. And according to this, the radius of my cylinder is going to be how about 4 meters in my radius, and it is going to be 30 meters high. It's going to be a big grain bin, okay? So what is going to be the surface area of this grain bin? Well, we're going to have a cylinder to calculate plus half of a sphere. So you're going to have a cylinder plus 1/2 sphere. And this is why it is important, guys, to calculate and decide your shapes. On this cylinder, because the upper base of the cylinder won't be included, you only have one base plus the lateral surface area. So your base of your cylinder is pi r squared, only one of them, plus this one's going to be pi times diameter times the height. So pi, 2 pi, we'll just go 2 pi r, because 2r is your diameter, times the height, and that takes care of the cylindrical part, plus 1/2 of the sphere, and the sphere is 4 pi r squared. Okay? So we can calculate the surface area of this multi-shaped figure. We have a cylinder plus half a sphere. So this is pi times 4 squared plus 2 times pi times 4 times 30 plus 1/2 times 4 times pi times 4 squared. Okay? So 4 squared is 16, so 16 pi plus 2 times 4 is 8, and 8 times 30 is 240 pi, plus 1/2 times 4 is 2, 4 times 4 is 16, so 2 times 16 is 32 pi. Okay, do you see that? This is your cylinder part, this is your half sphere. So now adding these all together, and we can add them because they all have a pi, so they're like terms. So we've got 16 plus 32 is 48. 48 plus 240 is 288 pi. And that would be expressing it in relationship to pi. But now if we want to express it in relationship with actual square meters, we're going to go 288 times 3.14, and that's going to equal 904.32 meters squared. So that's how many square meters would be in the surface area of this particular cylindrical grain bin. Okay? Now, if you were going to paint that grain bin, you would have to know how much a gallon of paint covers before you could calculate how much to buy. But we're not going to buy any paint at this point. But that's a possibility that it could go that way. You could go that route. So now you have seen how to do surface area in some pretty complex shapes, and you can see you have to think, you have to analyze what are the shapes that you're dealing with. What kind of shape is each face? So remember, as you're looking at surface area or lateral surface area, you're looking at what is the shape, the faces. Because the shape of those faces determines the area and the formula you will use. So it's really important to determine the formula for the faces, and keeping in mind the number of like faces. I told you that there was one other polyhedra that we could do if we were to work on this. And this, in the Platonic solids, your tetrahedron. And we'll go ahead and look at that one too. Tetrahedron. Remember, your tetrahedron has 4 equilateral triangles. And if you remember, when we talked about area of an equilateral triangle, we discovered that the area of the equilateral triangle is the square root of 3 times my side squared over 4. Okay? And the reason why is your equilateral triangle has all 3 sides the same. So this is the side, and then when we bring down our height of that triangle, and this is also the same as that, we're going to end up with, to figure that, what is it going to be? Well, let's look at what that is. You're going to have 1/2 of S is this side, and that's H, and that's S. So your Pythagorean theorem is your H squared plus 1/2 S squared equals S squared. Well, I need to know my H, so I'm going to do H squared is equal to, and I'm going to subtract that 1/2 S squared from this side. And it's going to end up with S squared plus 1/2 S squared. So my H squared is equal to S squared plus 1/2 times 1/2 is 1/4 S squared. And now take the square root, so H squared, H is equal to my square root of 1 S squared, which is 4 over 4 S squareds, plus 1/4 S squared, which is equal to, it's easier to see it from the other. This would be 5/4 S squared, and that doesn't give me what I'm looking for. Let's do it with something on there. My H, let's make my side 3, okay? All my sides are 3. Make it easier. Let's make it 6. We'll go with 6, because I want you to be able to see where this is coming from. Okay? So, this H is going to be my H squared plus 6 squared has to equal 6 squared. So h squared plus, oh no, 1/2 6. This is going to be 3 equals 6 squared. This is 9, this is 36. So h squared is equal to 36 minus 9, which is 27. H is equal to the square root of 27, which is equal to 9 times 3, and the square root of 9 is 3, so this is 3 square root of 3. And this happens on every one of them. It comes down to this. No matter what your side is, it comes down to half of the side, because 3 is equal to 1/2 s. It comes down to half of the side times the square root of 3. And so for my area of that one triangle, since my height is 3 square root of 3, you have 1/2 times my base, which is 6, times my height of the triangle, which is 3 square root of 3. And this gives me 3 times 3, which is 9 square root of 3. Okay? And so that's what that is. But let's look at it in relation to s. This is s, so you have 1/2 s times this, which is 1/2 s, times the square root of 3. And therefore, 1/2 times 1/2 is 1/4. S times s is s squared, and square root of 3. And this makes it square root of 3 over 4s squared. And that's where that comes from. It's easier to see it if you use numbers than if you use all letters to start with. So, if we have a tetrahedron, and say that tetrahedron has a triangle of side, the side of this tetrahedron is going to be of the triangle, let's make it 8 inches, okay? So, the square root of 3 times 8 squared divided by 4, and that's for one triangle. Now remember, your tetrahedron has 4 of those, so this times 4. Okay? So what's going to happen here? Well, 4 times 4, 4 divided by 4 is going to cancel out those 4's, and we're going to end up with 64, because 8 times 8 is 64, square root of 3. And then let's see how that ends up. Square root of 3 is going to equal approximately 110.85 inches squared. So what's interesting about the tetrahedron, notice that when I multiply 4 times the area of one triangle, the 4's disappeared. So the surface area of a tetrahedron, tetrahedron, is equal to simply s squared times the square root of 3. So that's not a hard formula to remember if you want to keep that in mind. The rest of them we're not going to do, but this is what your tetrahedron is. It's s squared times the square root of 3. And that works out really nice. And it's only because the number of triangles is the same as the divisor of your one equilateral triangle formula. And I know I've showed you that before, but I wanted to go over it again because it's not something we remember very easily. I would recommend for all of you, get out some flashcards. Put the name of the 3D shape on it, and write down the formula, one card for each shape. So you can go over and over these formulas, because I will not give you the formulas on a test. So you will need to know them. So you need to get that written down and start working on it right now. Have fun, guys.